Hello everyone. Welcome to Leader Associates Impact Hydrogen Driving Sustainable Transport in Japan towards a hydrogen-based society. My name is Molly Huang, Content Team Lead of Leader Associates and your host of today's session. To start with, I guess many of you may wonder why we choose this topic. Hydrogen, transport, Japan FCEV. It doesn't sound like a good combination because over the past few years, we have seen so much rise and falls. And despite all the efforts, the sector itself remains at a young stage of development with limited demand and business cases. I can even recall the day we released the topic, many of our followers commentating below the poster, challenging why. I direct the same question to Mr. Eiji Ohira, Director General of the Fuel Cell and Hydrogen Technology Office of NEDO Japan. And here's his answer. Molly, this is a new and challenging sector. We don't have enough experience. We are and will continue to explore it by investing into the R&D. But still, the mission cannot be achieved by one country only. It requires collaborations among different counterparts and different allies. So here we are today with 6 top industry experts, providing us with ideas and examples from Japan, from Germany, from the UK. And the ultimate goal is to break the mainstream concepts and to jointly forge the future. But before we get everything started, I want to introduce once again, we are at Leader Associates, in case some of you are not familiar. Leader Associates is a global leading clean energy event organizer, hosting solar, wind, and hydrogen events across 5 continents, including Europe, MENA, Australia, Japan, and Southeast Asia. On October 11th to 12th, we'll also be hosting our second Connecting Green Hydrogen Japan in-person event in Yokohama, which serves to link the global hydrogen value chain to Japan's multi-billion sector. And this is everything about us. As today we have a very compact schedule, without further ado, I'd like to hand over the floor to our first speaker, Dr. Katsuhiko Hirose, CEO and Chief Consultant of HyWealth, Japan. And more especially, Dr. Hirose-san is also the developer of Toyota Prius and Mirai. So I consider him as the pioneer of Japan's future mobility transformation. Dr. Hirose, I welcome you here. Please take the stage.
Okay, so good afternoon, good morning, so everywhere. So Japan is still very hot today, so 35 degrees outside. So I'd like to start. My presentation. Okay, can you see my presentation?
Yes, we can.
Okay, so thank you very much for the introduction and a great honor to talk on these topics. So as I said, I've been working for years for automotive sector and also the hydrogen. So I'm still chasing the hydrogen to a sustainable low carbon society. So our goal is not the decarbonized society or just handling the issue for the climate change. Our goal is a sustainable life. So today's topic is, I'm talking a little bit about what's going on in Japan, especially for the transport and energy sectors. So Japan's effort for hydrogen, it's already more than 30 years in early stage energy sector, and also the local emission. It was a problem for especially for a big city like Tokyo. But now, actually, most of the emissions are not due to from the transport now. So the emission vehicle is not very important for Japan to solve the problem of the local emission. And now the target is changing because of the hydrogen will be a very important vector for carbon neutral society and also the green growth strategy. So historically, Japan led the world to adopt the hydrogen strategy. So in 2017, Japan was the only country to have a hydrogen strategy. Now we have many, especially in after 2020, 21, and also now even we have some like a hydrogen strategy for Saudi Arabia. So that's a little bit surprise, but because of the hydrogen is very important for all over the world. For decarbonization, this is the energy, or actually the carbon dioxide contribution of Japan. So energy conversion, everybody talking about the power generation, whether we need to use nuclear power or PV or renewable. But very important thing is energy conversion is only 1/3 of the carbon dioxide emission. The 1/3 from industry like steel making or cement or this, and also the quota from transport. So many people talking about the carbon dioxide emission, the climate change about blaming the transport, but the transport is only 25%. But as a transport using a huge, very expensive oil, so this is different. So this is a carbon neutral strategy of Japan. So current more than 1 gigaton of the carbon dioxide emission need to go down to 0 in 2050. So, and Japan set the policy in first to reduce the cost of hydrogen, then showing the moderate target. But last year, because of the carbon neutrality, they set a higher target, but still, compared with Europe and the rest of the world, it's still moderate. And also the hydrogen strategy, Japan was aiming to use more hydrogen for the transport. Because of that, this is a hydrogen price parity. Actually, the oil, gasoline, is the most expensive per energy. So on the left is the actual cost of the energy, and the right side is equivalent hydrogen price. So already for passenger car, hydrogen price at the hydrogen fuel station is parity. But to go beyond this, the hydrogen need to be cut the cost further. So this was something, so that the Japanese government tend to use the strategy to put in money for R&D to go to the reduction of the cost, then industry will use. But situation is changing drastically in the last year or more. This is the data from the Hydrogen Council. Because of that, until 2030, the blue hydrogen seems to be the cheapest, and green hydrogen will be competitive in 2050. So this means the use of more blue hydrogen and green hydrogen later. That is something that people thinking practically. So, but this is changing drastically. So this is some calculation of the hydrogen parity the energy. So oil, I skipped many calculations, but think that oil $100 per barrel is $4.2 hydrogen per kilogram. So natural gas $10 per million BTU means hydrogen need to be $1.3. So this is why Japanese target of the hydrogen is around 20 yen per normal cubic meter because of the this. But Europe is now, natural gas is 167 euro per megawatt hour. That is something like $50 per million BTU. So this is the equivalent hydrogen is $6.5. So green hydrogen is already near this figure. And in addition, this is the value chain of the energy for blue and green. On the left is the blue hydrogen. The blue hydrogen, the black means the concession, that is we pay for the money for the country of having those resources like GCC countries. So economical, I can say, value chain is on top of those concessions, and then that will not change even the oil price going up. So, and then on the right is the green hydrogen. Green hydrogen is currently more expensive than fossil fuel. Actually, it was, yes, because of the oil was $60 per barrel. And with the $120 per barrel, with the CCS, blue hydrogen is almost same, or maybe a little bit more expensive at this moment. But if you see the real value chain of this, because of the concession is more than half of those costs. That means when we pay the cash, half of the money, or actually 2/3 of the money, is not going to the normal economy, like creating a job or giving another investment. But in case of green hydrogen, this is completely different because of the energy coming from PV, wind, and other renewable, and electrolyzer, so on. The cost can be a bit more, but cost means cash flow. Cash flow will be redelivered to the industry. So energy cost can be a blue hydrogen. Sorry, that's energy cost. This is different. Sorry, this energy cost can be better for the blue hydrogen than green hydrogen, but economic costs for the society can be better for the green hydrogen. So this is most of the people are talking about the energy costs, but if you really understand the economy, the energy transition means not only just the expense for the environment, actually the changing the delivery of the cash flow to the society. So battery or fuel cell is always talking about. This is the picture I wrote during the Hydrogen Council. The smaller car will be battery electric, and longer distance and larger vehicle will be hydrogen. And aviation and ship are a little bit uncertain. But very important thing is this is the distribution of the carbon dioxide emission. So actually, the small vehicle is high number, but the carbon dioxide emission is not so large. The large emission are coming from longer, larger passenger cars and heavy duty and aviation marine. So if we really want to reduce the carbon emission, we need to reduce. Aviation can be a loss, but recently there are a lot of discussion, and actually this is now very serious about the use of heavy duty truck and the aviation, even the marine. So this is the current status of the vehicles trend in the world. So small passenger seem to be battery electric, mid-size, large are still uncertain. And commercial vehicle, probably the heavy duty going to FCAV, and other like a bus, train, marine aviation is actually the mixture of the hydrogen. And for marine, maybe there can be some possibility of the ammonia or those. But anyway, this is the viewpoint from the emission point. But from the, I've been working for years for automotive industry. Priority of the choice of fuel for the customer is completely different from what we are thinking on the desk about the emission. Because of the cost of operation, fuel cost is one of the many aspects of the customers. Customer may compromise about the price because of the comfort, performance, but customers are not willing to compromise with the convenience. So when you think about the future mobility, the convenience is very important. So in this sense, I see the hydrogen fuel cell has a still very huge chance when the infrastructure can be available nearby. I skip this. This is a way how we construct the infrastructure. So I'm talking about the transport, hydrogen in transport in Japan. So now the JR, Japan Rail, are thinking very seriously about the use of the fuel cell for the diesel alternatives, and also the commercial vehicle. This is the current situation of hydrogen station. So actually 161 stations are in operation and covering more major cities and the major interlink, except northern main island. So I'm using a hydrogen car every day in the middle of this picture. So for day by day, there's no problem, but only when you go travel northmost or some of the very remote place, we need to find a hydrogen station. And also some people ask me that, is Toyota moving from fuel cell to hydrogen combustion engine because of the recently the racing? So because Toyota's president Akio is very favorable for the auto racing. So he wants the exciting car. So that, of course, fuel cell is exciting, but not only fuel cell, but also the combustion engine. So I'm originally engine engineer, so I know quite well. But the Toyota is not moving from fuel cell to combustion engine. Toyota's intention is there need many solutions for decarbonization of the mobility. Not just electric vehicle, but electric vehicle is a solution. So we need to think much more, and there's a many chance for many applications. I personally do not think the hydrogen combustion engine for the passenger car is possible because I've been working for years. Good for the racing car, but not for the everyday. But this is the latest Mirai, and also this is something about Toyota is now, I took from their presentation. Their strategy is very simple. They are mass producing a fuel cell unit for Mirai because the passenger car is high number. So then the cost down can be through this mass production, and then deliver to many like heavy duty or light commercial or even for the lunar vehicles. And very important thing, this is from the ENA presentation. The 40% of the fuel cell the patent, really, more than half of the fuel cell patent are from Japan. So Japan has still very strong point in terms of the technology. And the conclusion is Japan policy is previously concentrated for R&D, but now shifting to the implementation of hydrogen into society, large infrastructure investments with the government and private sector is ongoing. And also the recognition of the domestic supply of the hydrogen. Because of the current situation in Japan is energy security is getting more and more serious because the exchange rate is from previous 110 per dollar is around 100, nearly $40, 140 yen per yen. So that means in addition to the high energy price, this falling exchange exaggerates the energy costs for Japanese economy. So, and also the renewable energy cost is going down drastically. Recently, the Mitsubishi beat the offshore wind for around 10 cents per kilowatt hour for offshore wind. This was rather big surprise for everybody. But this is not big surprise because this is similar to the cost or a bit more than Europe. So potential of domestic renewable is getting more and more important. I will skip. And this is energy import of Japan. Probably this year will be more than $200 billion per year for 2020. And this is, I'm personally pushing this because of we have a huge renewable in Northern Ireland, like Hokkaido or Kyushu. If you convert those energy into the hydrogen and making a pipeline, as Europe is now planning, Japan can use domestic renewable as a hydrogen as a domestic renewable, both in central Japan, and also this may reduce the energy security. And for Japan, this is conclusion. Chance of carbon neutral means we can design the future. The hydrogen can be a basic backbone structure. And I like this, and thank you very much.
Thank you so much, Dr. Katsuhiko, for your kind address and for the quotes. It sounds that you are not an optimist for the transport market at the moment because you say the Japan policy is shifting from transport only to a wider coverage. So my first question to you is a bit tricky. Is the vision for fuel cell cars that in Japan or in other countries from your perspective?
I think that as I said, hydrogen is an important vector for decarbonization. It was really recognized in Japan. So because of Japan was so early that cost competitiveness is only for transport. That's why Japan was pushing the hydrogen infrastructure and the fuel cell. But now, same as rest of the world, Japan is now really recognizing hydrogen is very important for not only just transport. So they do not deny the importance of the transport, but they recognize the wide the use of the hydrogen. So that's my answer. Yes. Okay.
Yes. To summarize, you think that Japan is strongly promoting the hydrogen vehicles, but just to expand from the passenger vehicles to commercial vehicles as well. So yes, you think will be huge potential in the future. And I see there's one question from the Q&A box asking how many refueling stations the Japan would require to satisfy its demand for the transport sector. So, before we addressing the number of refueling stations, how much demand of hydrogen do you foresee for the Japan market?
This is something. So I simulate the necessity of the hydrogen station. So if you have a hydrogen station from your home, 5 kilometers, so 10 kilometers diameter, that's enough for this, you need only 2,000 stations for years. But we have 35,000 petrol stations in Japan, but it used to have more than 60,000. So now they are closing because of the it's too many. So they cannot gain a lot of profit. So it's going down. But probably I personally think that 3,000, 4,000 enough to cover all the demand.
Thank you. I think Martin would be very satisfied for your questions. And one last question before we hand over the floor to our next speaker. The question is from Kim regarding the hydrogen carriers. So we have liquid hydrogen, LHC, methanol, ammonia, perhaps. Which carrier do you root for?
I think that so to consider the future, so there is some. So as you mentioned, that those can be all bridged for the future because easy to handle, easy to store. But if you think about the importance of hydrogen in the future, I think the gaseous pure hydrogen or ammonia will be a remaining carrier, and LHC will be a little bit disadvantage because you need to bring the carrier back to the original. So, so maybe the long term, the liquid hydrogen or pipeline or ammonia, that is my personal, this is rather sorry, personal opinion. So, but for a while, they are competing each other to the cost of transport. So for another 5 or 10 years, they are competitive. Yes. But there will be no one solution. Yes, that's my answer.
Thank you, Dr. Katsuhiko. And I want to remind our audience that we will have a specific Q&A section at the end of today's webinar. So please feel free to raise with your questions in the Q&A box. And today we will try to accommodate as many questions as we can. And also to Dr. Katsuhiko-san, I appreciate if you can stay a bit longer for the Q&A part.
Okay, I'm waiting.
Thank you. And now let's switch the side to Germany and to the heavy duty sector. With great honor, I'd like to introduce Mr. Gerrit Stumpe, business developer e-highway at Siemens Mobility. In Gerrit's capacity, he is responsible for market analysis and the preparation and pre-acquisition of e-highway projects. He is also an associate member of the Working Group Committee for Emerging Freight Technology of World Road Association. Mr. Gerrit, I welcome you here.
Thank you very much, Molly. Thank you for the introduction. It's really kind for having me here today, and hello to everyone listening to this call. Yeah, thanks again for having me here. What I've brought here today are coming from hydrogen economy and a view of all the sectors and the potential application in the future and also the current applications of hydrogen. I would like to take you within a short quarters of an hour journey to the road freight transport sector and solutions how to decarbonize this specific sector. We know this is a complex sector. It's not that easy, and it's a very relevant sector too, and it's really worth looking at this and more in details because we're having Paris Agreement in mind and also national legislation how to counteract on global emissions and national emissions specifically. It's not that easy because heavy duty transport, specifically the heavy duty trucks, play an important and dominant role in emitting CO2 emissions. And the trouble is, or the dilemma is, we are heavily relying on them. So what's in now for today, I'm going to share my presentation in a short minute. And please tell me if it's visible for you at all.
Yes, we can see it, but you need to put it in full screen.
Yeah, I'm desperately trying. Maybe it needs an extra click. All right, there we go.
Go ahead.
All right. So this is not just, this is just a nice picture from, let's say, what we've built in Germany. I'm going to refer in a minute to this. So, well, as I said, we have, let's say, to do the transition in each of our countries. And the transition from nowadays fossil fuels used for heavy duty vehicles like those trucks displayed here is a very difficult and challenging one. So there are some different options on the table. We could think about using hydrogen for using them inside fuel cells to propel and power those heavy duty trucks. And they have, of course, some key advantages using this kind of propulsion system. And they have also some difficulties. The main advantage is, of course, that, let's say, there's a much higher power density compared to the battery electric vehicles. And they are giving much more range, which is, of course, a very big and an important issue for logistics companies. Then we also could, let's say, try battery electric powers, and there we saw really an impressive upswing, specifically in the light duties vehicles for some years now, even now. And global OEMs now even started mass production and announcing promising new vehicles arriving on the market soon to overcome this. However, we need to keep in mind there's a scarce and a limitation on the resources like lithium. This is not an easy task to overcome, I guess. And still, next to the very heavy weight of these large batteries, they offer only a limited range. And then next, we could also think about using hybrids with synthetic or biofuels, which of course also have their pros and cons. This would be best, of course, in the transition of nowadays fuels and also fueling infrastructure. But all of these, let's say, have some difficulties, and this needs to be overcome. And if we think about how to combine these rather different approaches, fuels and infrastructure, we at Siemens Mobility have invented something which has been known for decades in railways, and this is overt catenary. So if we think about to combine these kind of trucks, rather different trucks, within a collector, which we call a pantograph, connecting to wires, we see not only direct electrification, but we add on a very high efficiency to those trucks using this. And why is efficiency playing such a dominant and important role in this sector? I'd like to draw your attention to the outcome of a Fraunhofer study done some years ago. If we talked about TCO, the total cost of ownership, and the view of well, the owners of infrastructure, but also from the perspectives of the hauliers and logistics, it's possible and necessary to split up this TCO in some important parts and pieces. And this is the energy supply for one piece, then the energy infrastructure, the cost for them, and also the purchasing cost for a vehicle, making the total costs. And there, let's say Fraunhofer made a very interesting assessment for the renewable fuels or synthetic fuels, the overt catenary, and the fuel cell electric vehicles. Again, this is all for trucks here. And it is clearly visible that, let's say, it is not about the energy infrastructure. If we compare these two, it is rather the energy supply. So TCO is mainly driven by energy costs. And this is worth, let's say, looking where you get your energy from and what does it cost you as an haulier. So at Siemens Mobility, we started, as I said, already 12 years ago with some initial testing on our test facility near Berlin in Germany. And we tried to bring up such a collector on top of a truck and also even on the tractor trailer, which is the so-called working horse in industry and trucking industry. And we proved it's really working. We also made demonstration tests in the US with different propulsion systems. We also went to Sweden to test the system under winterly conditions, and the very first time in daily operations for local hauliers and transport companies there. And then we made our first attempts on German motorways just 3 years ago with this nice truck here with a third generation of pantograph. And since July last year, we made a cooperation with Continental, the automotive first-tier supplier in Europe, in preparation for the industrialization and mass production of these pantographs. So this solution is using wires, using direct electrification, and it offers all the advantages of what an haulier needs. And the system is very flexible, so you can connect and disconnect at any time and at any speed, if you like. And let's say, thanks to your battery or your onboard or a secondary engine in terms of a concept, you can also make your way outside the electrified section. Now, this is a view to show that this system is also complementary to existing and also future drive technologies in fuels. The one highlighted with bluish, we tested all out. So it's mainly about the tractor, but also we tested a rigid truck. We had full electric, different concepts of hybrids we tested out. And then depending on the battery sizes, we also had this all. We did different engines. And of course, we tested also different kind of fuels. The only one still missing, we are eager to test this out easily. We are eager to test this out as well, is of course the fuel cell and the hydrogen in combination with the pantograph. So what we've been doing now, following Germany's approach by the help of the German government, we set up 3 field trials to test this system out in daily operations on public roads. So we chose 2 motorways, the one near Frankfurt on a 5-kilometer stretch, and another 5-kilometer stretch near the Baltic port of Lübeck. This is near Hamburg. And then in the southwestern part of Germany on a very curvy valley federal road there with a 3.5 kilometers. All of these use 5 hybrid trucks. So they have a diesel engine and they have an electric engine. This is a parallel hybrid concept they are using, and they are receiving the electric energy directly from the wires. Maybe it's important to know that we have started extension works already here near Frankfurt with another 7 kilometers in one direction and more than 7 trucks to follow. And how we did this. So you see some pictures how this was done near Frankfurt. First of all, some sort of a ground investigations, if the poles could be set. Then you see these machine drilling and ramming those steel pipes into the ground, were soon erected. And all these works here were done without interruption of the running traffic, because let's say the motorway operator near Frankfurt just said, well, this is so busy road. We have, let's say, 150,000 cars and 15,000 trucks per day passing by. There's really hard to do any interruption and construction works doing on this specific section. We had some temporary closure of the roads during the weekends or the Saturdays where we mounted the cantilevers and then we drew and pulled the wires and fixed them. And next to the motorway, here in this case on a service station, we erected and installed the substation and connected them to the infeed masts, providing, in this case, renewable power to the trucks driving there. So this is all nice efforts. This is all nice shown that this technology really works under daily conditions, ordinary conditions. But it needs, of course, federal or let's say governmental help and support. Not only this concept in general, if we think about to transition to an emission-free trucking world, Germany's government decided to choose a technology open approach. And with our system, which we call the e-highway, we are very confident to meet this. As you can see here in this overview, there's the abatement cost shown for battery electric truck, for fuel cell truck, and also for the overhead catenary truck. Those numbers means these are 443 euros per ton abatement costs. This would cost it if you choose battery truck alone, fuel cell truck alone, or also the overhead catenary truck alone. And this is in context to be seen with the TCO of each kind of the trucks. For the diesel as a reference and comparison, battery, overhead catenary, and the hydrogen one. So it clearly shows, let's say, there are different elements in costs, but the yellow one is again the energy. This is all about it. and the energy is driving those costs. So when choosing or taking decisions on how to move forward, energy is, let's say, the dominant element which needs to be considered in such a decision-making process. And this decision-making process set by the government was more put into detail just last year when the Federal Ministry for Transport published its technology roadmap. And this is only a fraction out of it. And so the government endorses the further testing and build out of overhead catenary lines on motorways, because there's the most sense to erect this, as there are, let's say, thousands of trucks passing by there on a daily basis. And this is a time frame where we think to see some more R&D and more development and testings, followed by decision-making process somewhere in that timely area, and then the decision for further scaling up and rollout in order to meet climate goals already by 2030 and beyond. The ministry also made some more highlighting about starting 3 larger projects. So a battery electric one with mega charging systems, and then 2 innovation clusters in Bavaria and also in the southwestern part of Germany in 2 states, where, let's say, the overhead catenary should be used or intended to be used as an energy backbone or an energy carrier, serving to trucks like full electric or also hybrid, using hydrogen, for example, as a future fuel, combined also with hydrogen fueling stations. Now, saying this is, let's say, the picture I wanted to show you. And then this is cannot be done in Germany alone. I mean, we are a transit country where, let's say, all our neighbors, let's say, have their transport passing by through Germany on a daily basis. So thinking of this solution or of any solution, it needs to be done in a harmonized and also European way. This is why my colleagues in engineering are working on an open standard, which is to be expected by end of this year. And next to this standards, of course, there's a very high interest in this technology, on this approach by many European states, showing, let's say, they would like to do feasibility studies, or they did already, with very promising results, or even eager to set up electric roads and overhead catenary by themselves. So to conclude and to sum it up is the overhead catenary solution for trucks, namely the dynamic charging, is combining all these advantages we already know from railways for decades. And we also have an industry in place which is capable to meet this demand and to build this on roads. It can be realized in the international context, not only in a European one. It is fully flexible and compatible to other fields and technologies. It's the most economical one, and it can be quickly rolled out. This is very important, I think, in order to reach climate goals already by 2030 and beyond. So, having said this, I would simply like to draw your attention to these 2 fine movies we made. And yet there you can see this system in operation, if it's not possible to come to Germany and see it real there. And I'm really happy and looking forward to any of questions with this set. Thank you very much.
Hey, Gerrit, my screen is freezing. I wonder if you have finished your presentation?
Yeah, I'm about to finish.
Finished already?
Oh, yeah.
Sorry, my line was dropped. But thank you again for the very informative and comprehensive sharing. Some audience are asking whether we can share your presentation slides to them.
You sure?
Yes, and also we have one question from the Q&A box. It's from Miss Mid Beria. So she's asking about the infrastructure cost of the e-highway. because it also involves additional construction of poles and wires. So can you elaborate more about that part?
Yes, of course. And thanks for raising this important question. It's all about infrastructure, and infrastructure is always needs to come first of any possible technologies placed on vehicles. So coming specifically to the costing question, there have been some sort of assumption made by many studies, not only by one, not only by German studies, but also by European and also international studies. And it shows there are some slight differences among the countries, as this system or the infrastructure, to be more precise, uses steel and mainly. This is driven, of course, by commodity costs. And study shows, before, let's say, the conflict in the Ukraine at least, that the price per kilometer should be around 2.5 million euros per kilometer, serving in both directions.
Yes, and also a follow-up question regarding the cost of hydrogen itself. So any estimation on the price in the coming years, and for the e-highway, you are using liquid or gaseous for your vehicles, and how do you tackle the refueling challenges and maybe related safety challenges?
I was most afraid of this question, but thanks anyway for raising this. This is I'm focusing to Germany now. This is highly dependent on, let's say, how the electricity sector is built up and set up in Germany. This is first. We still need to do a lot in order to get, let's say, more windmills and more solar farms built up here. Also sharing renewable energy with our European neighbors and friends. This is one thing. The other thing is then, how is this hydrogen produced and transported to the filling stations? There's quite an uncertainty, I'd say, and I noticed. It's rather difficult to put this in one number, but as you asked me, I'd say there's a range about 6 to 10 euros per kilogram estimated in studies. But I would like to make quite clear that I'm not the very expert on this. Regarding those innovation clusters, which I briefly introduced, is that all the member states or the states of Germany are now setting up a chain of hydrogen stations already in operation or in operation very soon. And they will be offering 350 and 700 bar pressure levels. If the question comes to liquid hydrogen, although this has not been decided yet, at least to my information.
Thank you so much, Gerrit. I believe there will be more questions coming up for the Q&A part. And I appreciate, again, if you can stay a bit longer.
My pleasure.
Thank you. And the next is a joint presentation, which we all expect. It will be presented by Deutsche on railway decarbonization. In Japan, we also see some similar trials developed by JR East. But what exactly is the approach did by the German, and what lessons can we learn from? I believe Mr. Markus Zimmermann and Mr. Christian Pieper will provide us with a fresh perspective. I welcome you here.
Thank you. Thank you very much for the kind introduction, and thank you for your interest in our project. One of the key questions, Christian, can you share the presentation?
Yeah, I will share.
Yeah, so one of the key questions we are getting asked if we share our project is, why does the Deutsche Bahn need hydrogen at all? Don't you have all lines electrified? That means under an overhead catenary line, like Mr. Stumpe said before. The answer is yes. The majority of the tracks does have an overhead catenary line. It's approximately over 60% now, and the objective is to increase that up to 75 over the next decades. However, a portion will still remain without an overhead line, an overhead catenary line, and yeah, we need to replace the remaining diesel fleets, the remaining diesel vehicles which are still in use on those tracks. Hence, we need to find climate neutral alternatives, and one solution is a battery fuel cell driven train. So if we start with a short look at the climate targets from Deutsche Bahn, we will become, or our objective is to become climate neutral by 2040. And as I said, one key element is to supply the overhead line with 100% renewable energy, which will then cover most of the transportation sector, as well as the buildings, so stations and depots. By 2030, approximately 80% of the energy will be renewable in the line, and 2038 it will be 100. On the other hand, for the tracks without the overhead catenary line, the aim is to order no diesel fleets anymore from 2025 onwards. This for sure requires support from the states in Germany who are negotiating the traffic contracts with the operators like Deutsche Bahn. So it requires a political will to not order any diesel fleet anymore. For example, we currently have the state of North Rhine-Westphalia, which is currently in process to sign a new political coalition contract, which exactly states this. So they write down that it's not allowed to order any diesel fleets anymore from 2025 onwards. Next slide, please, Christian. So, but still currently there are approximately 3,000 diesel vehicles in operation. 25% each are cargo transport vehicles or railway construction vehicles. And the other 50% are used in regional traffic. And you can already see from this slide that there are different use cases we need to take into consideration. So we have heavy and light loads, we have long and short distances, and due to the life in service, we have existing and new vehicles we need to take care of. So this requires a variety of technical solutions, and we will require a mix of those solutions. So like Mr. Stumpe said, it's a technical openness that is required to achieve the target of climate neutrality. So that means to replace all diesel vehicles. Next slide, please, Christian. Quite similar to what we saw before. So this provides an overview of the technical solutions we are currently looking at. If you start from the bottom, the alternative fuels had been mentioned as well before. So we're talking about biogenic fuels like HVO or synthetic e-fuels. They will be a supplement, especially for high load traffic. And they can be used as a bridging technology for existing vehicles which still are in service for quite a while. However, currently the alternative fuels are very rare on the market and so quite expensive. But we are running projects as well to test those fuels during operation, so durability and as well the economical side. Battery electric vehicles in the middle, they are the best choice for short ranges, up to 100 and 150 kilometers. This can be sufficient if you have stations which do have an overhead catenary line connection and sufficient time to charge the battery before the vehicle needs to leave the station. Yeah. If you think about more range, then fuel cell vehicles come into play. They require two technologies, so a battery and a fuel cell, but they can cover ranges up to 600 and in the future even more, 800 to 1,000 kilometers. They store the renewable energy in form of hydrogen on the vehicle. However, due to the two technologies which are required, they are more expensive, and for sure they require a hydrogen infrastructure. And as said before as well, profitability will be heavily depending on the costs for hydrogen. Again, this is a lever where the regulation will come into play as well. Next slide, please, Christian. So To make a new technology like a battery fuel cell vehicle ready for the market, you need to test durability, you need to challenge profitability, and you need to see the vehicle during daily operation and under all circumstances. So what we are looking for then is an implementation of a whole ecosystem. That means the vehicle and the required infrastructure in terms of hydrogen supply and vehicle maintenance. Furthermore, to ensure the climate neutrality, we need to be using renewable energy, and we are looking for an on-site production of green hydrogen with our project. So in quick summary, H2 Rail, our project, is implementing a solution that utilizes green hydrogen and therefore can support to achieve the climate targets at Deutsche Bahn. With that, next slide, we take a more closer look at the project. Here you can have a first glance at the different elements. Yeah, this one. A first glance at the different elements of the project. So starting from the upper left, you see the renewable energy in the catenary line, which then supplies the on-site electrolysis in the upper middle. The green hydrogen will then be stored at the filling station. And the filling station is capable to fast refuel the vehicle. That means approximately in 15 minutes. The vehicle will be in operation for 1 year, which then includes the maintenance of the vehicle. Okay, Krista, next slide. So some key facts of the project. We are a funding project, so financially supported by the government via a program which funds innovative hydrogen projects. In total, we are 4 project partners. First, the Deutsche Bahn Holding, in concrete, the technical area where I am working for. We are responsible for the overall project lead and project management, and as well support with experts coming from the alternative drive area. Secondly, there's DB Regio, that's the regional operator from Deutsche Bahn, who is responsible for the 1 year of operation and maintenance. Third, it's DB Energie, that's the energy supplier from Deutsche Bahn, who is responsible for the hydrogen infrastructure in our project. And last, we have Siemens Mobility as our external partner in our project, and Siemens is responsible for the development of the vehicle at the end, then making it homologated for the track. Our project started at the end of 2020, and we will continue until early 2025. And the 1 year of operation is in 2024. Next slide, Kristen, please. A quick look at the vehicle, some more details of the vehicle. It's the so-called Mireo Plus H. It is a new vehicle which is based on an electrified platform, so that Siemens can ensure that the hydrogen version will have a comparable performance to an electrified vehicle. The mileage, as stated before, currently estimated up to 600 or even 800, and it is capable of fast refueling. There will be as well a version later on which will cover more range, up to 1,000 kilometers. From Deutsche Bahn side, we support Siemens during the development of the vehicle to ensure that it's optimized for the operational requirements. Next slide, please. Here you can see the maintenance facility that's in Ulm, in Baden-Württemberg, in the southern part of Germany. The depot will be upgraded to ensure that we are able to service the vehicle in a safe and capable manner. So the maintenance as well will be done in conjunction with staff from Siemens Mobility. As well, very important to mention is the training of the operational and the workshop personnel, as well as the local first aid staff like fire brigades. Next slide. Yeah, that's the track. It's Tübingen-Pforzheim, so a very local area, but a very typical track in the regional area of Germany. It's a one track only with various tunnels and bridges, and you only have higher customer demands in the morning and in the afternoon rush hours, but not comparable to what you have in the big cities. You know? So this makes the construction of an overhead line for this, let's say, topography quite unattractive. So we'll say very unprofitable. During the 1 year of operation, the vehicle will run approximately 120,000 kilometers, and during that time frame save approximately 330 tons of CO2, as it will replace a diesel vehicle which is currently running on that track. With that, I'm leading over to you, Christian. You can start with a more detailed look at the hydrogen infrastructure.
Yes, thanks, Marcus. And thanks, Molly, for inviting us to the webinar today. It's a pleasure introducing myself, DB Energie and Deutsche Bahn. Yeah, like Marcus said, we at DB Energie are the grid operator and the energy supplier or hydrogen supplier for the Deutsche Bahn group. That's why we are responsible for the hydrogen supply in this project and funding project. That means we operate the infrastructure close to the route that was just presented by Marcus. Our concept consists of different units. These are the electrolyzer, our mobile storage trailer, our mobile refueler, and the compressor unit. Last but not least is our DD communication interface between train and infrastructure, and the wireless communication interface which we developed in this project is completely new. Yeah, let me start with our production side, the electrolyzer and compressor. We use 100% of green energy to produce green hydrogen. Our daily production is up to 200 kilograms of green hydrogen.
I guess you need to higher up your voice a bit.
Oh, okay.
That's appreciated. Thank you.
Let me have to switch on my headset. Is it better now?
Louder, please.
Can you hear me now?
Yes, better. Thank you.
It's better, yeah? Perfect. Thanks for the advice. Yeah, I will start forward. So we have our electrolyzer and the compressor unit. We use 100% of green energy to produce green hydrogen. Our daily production is so up to 200 kilograms of green hydrogen. And after we compress the hydrogen to 300 bar in our mobile storage trailer. Then we come to our mobile storage trailer. Just a few facts about it. It has a capacity of 900 kilograms with 300 bar. Through controllable pneumatic valves, the optimal emptying of this trailer is given. This sets our high flexibility for its usage. The last unit in our concept is the mobile refueler. The mobile storage trailer is connected to our mobile refueler. From there we could get the hydrogen out of the storage trailer and via the mobile refueler and refuel the trains. The mobile refueler is the first mobile and flexible refueling station on wheels for the railway sector, but we can also provide hydrogen for buses and trucks. In one refueling operation, the refueling quantity is about 180 kilograms. So on the next slide, I come to the last innovation in our project for the communication interface. Newly developed wireless communication interface works between train and infrastructure. The exchange of data sets on pressure and hydrogen is possible via this interface, reducing energy consumption and refueling time. So I will come to the next slide. Here we had planned our commissioning and test refilling in mid-2022. Now we are started the commissioning in the test center of Siemens Mobility. There we test our hydrogen delivery concept and supply concept, and want to check and optimize the whole system. So on my next slide, you see some pictures of this site, and we at Energie constructed there our filling station, which was carried out in the test center. And in this project, the site acceptance test and the commission were accompanied by TÜV Süd. The TÜV Süd is an approval and monitoring center of this project. So I will come to our last slide, where we show you the test refilling. It's a part of the approval process, what is accompanied by TÜV Süd. It was conducted on the 15th of June. We conducted our first successful test refilling. In the future, we will continue working on this process and would like to grow our knowledge as much as possible. Yeah, that was it from our side. Thanks for participating. Don't be hesitate to ask any questions. Thank you.
We all know the public transport like railway is highly linked to the government support. So if there's one support that you would like to ask from the German government, what would the support be to facilitate the sector development?
Yeah, as said in our presentation and the presentation before, the cost of green hydrogen is the key factor. So it consists of renewable energy in total, so supply of sufficient affordable renewable energy, but as well, if you come down to green hydrogen, there are still political levers left which will help to bring the costs down. Just mentioning one element, you have the so-called greenhouse gas quotes, which enables a trading, and that is already established in local public transportation, but it doesn't apply to rail traffic yet. So the use of green energy is not supported, is not covered in that trading of quotes yet. So we can change that quickly, and that will bring down costs of green hydrogen for the rail sector immediately, and to a quite high number. But that's only one element. That's only one element. There are a lot of elements as well in the, let's say, which makes a business case more affordable, like investment support and so on. So it's quite a variety of measures where we can, or where we need political support, especially in the ramp up phase.
Yes, I hope the Japanese government could also adopt some of the measures have already been done in Germany and further develop the sector in Japan. And I thank you so much for your presentation, Marcus and Christian. Have a rest. We'll get back to you later.
Thank you.
You're welcome.
Thank you. Yes, and our next speaker is Mr. Hidetaka Edo-san. Senior Manager of Environment and Energy Business Division of Mitsubishi HC Capital. And now we will have some more perspectives from the lender side. Endo-san, I welcome you here.
Okay, hello. Thank you very much for this opportunity. And this theme is hydrogen driving Japan's sustainable transportation toward the hydrogen society. Okay. And my theme is unlocking hydrogen infrastructure finance. What's the key constellations and restrictions? Okay. So may I share my presentation PowerPoints? Okay.
Yes.
May I share? And I want to control my slide by myself.
Yes, please
Okay.
share the slide.
Okay.
Yes.
Okay. It's this one. Can you see my slide? Okay.
Yes, I can see the slides.
Can you see my slide? Okay.
Yes, I can see the slides, but it's not in full screen mode.
You can see? Okay.
Yes.
Yes.
Yes, I can see it now.
Okay. Okay. So about finance is in Japan. So Japan started the hydrogen infrastructure business at around since 2015. Toyota released the Mirai FCV, and Toshiba released the H21 automatic green hydrogen energy system in the Japanese market. So since 2015, so Japanese markets understood the financial scheme. So private and public sectors have collaborated with constructing the suitable finance support scheme. So I think it is on a pretty good level, I think. Of course, it will develop in the future based on the market needs. And I want to explain the outline of the Japanese finance support scheme. At first is technology innovation. Yes, Japan have a good innovative technology about hydrogen, especially transportation. And last year, 2021, Japanese government established the Green Innovation Fund. The fund size 2 trillion yen. It is equal to $10 billion US dollars. So such a green innovation fund supports to develop or facilitate the hydrogen technology. What kind of hydrogen? Of course, including transportation. So this supports 19 projects. And in the 19 projects, there are 3 transportation hydrogens projects. One is a smart mobility energy management, 2 hydrogen airplane, and 3 hydrogen and ammonia ship. Yes, I will explain after that. And so private sectors, yes, public sectors enthusiastically supports to facilitate the hydrogen infrastructure in the Japanese market. And on the other hand, commercialize its business level. So, many companies now want to explore their business chance in the hydrogen. So many Japanese companies want to invest something hydrogen challenges. So and major hydrogen leading companies, for example, build up the SPC or joint venture, Gerrit, and they started the hydrogen infrastructure business. So many Japanese companies, Japanese players investment or search the O&M business chance with such a SPC or joint business. So it is the private sector's efforts, very active. And in addition to that, public sector, government granting aid and local government subsidy support such SPC or joint ventures activity. And not only the governmental agencies, financial, public and private financial sectors support those activities, those efforts. For example, JBIC, Japan Bank for International Cooperation, and JOGMEC. JOGMEC is a kind of the energy development support agency, and DBJ, Development Bank of Japan, pension fund, private banks, is a kind of the my parents' company, MUFG, and private funds support the fund and loan to the new challenge about the hydrogen business development. Okay, but top point is the off-takers. Whether can off-takers induce the hydrogen infrastructure or not? Because capex perhaps 8 times or more expensive than the coexisting infrastructures, and OPEX, especially fuel, cost of fuel, will be more than 5 or 10 times than the current energy fees. For example, city gas or LP gas or oil and so on. Yes. So finance scheme and each company's challenge have been on the good level, but off-takers, users, it means the users of the hydrogen infrastructure hesitate to induce such a cutting edge and unprecedented, no successful example infrastructure. They need, they are considering even now. So, in a nutshell, financial scheme can support the hydrogenated transportation challenges is very good. I think reliable, I think, but users hesitate to induce the hydrogen transportation infrastructures due to capex and opex, especially the price of hydrogen. Current present condition in 2022 in the Japanese market, hydrogen 100 yen per normal cubic meters. It is equal to the 0.74 US dollars. It is too expensive for the users. So we need Japanese business side need to reduce the cost of the hydrogen. The Japanese government target is in 2030, 30 yen. It goes 0.22 US dollars, and probable about the 2050 or so, we want to reach the 20 yen, and it means 0.15 US dollars level. In that level, perhaps users easy to decide to induce the hydrogen transportation infrastructure. In order to achieve that level, so Japanese private, public and private collaborate to explore the preferable market conditions. For example, it is a green innovation funds one project. It's a smart making a smart mobility society's practical test. So as you know, Japan have developed the FCV, FC bus, FC truck, FC forklift, or FC train, but it is only physical items. We need the hydrogen transportation society. It needs to be the cost effective. So cheaper hydrogen free society. So Japan will have a practical test to operate the FC bus in the some area in Japan, and watch where is the best position of the hydrogen station, and where how operates the FC bus or FC truck in the route, and the people who live in that area will be happy or easy to use FC or hydrogen transportation solutions or not. So through such a practical test, we will find the best practice of the hydrogen transportation design city. And next is the next Green Innovation Fund's trial is the airplane, hydrogen airplane. As you know, hydrogen airplane needs a 4 times scale tank compared with the coexisting jet fuel tank. So airplane needs a liquefied hydrogen tank. KHI, Kawasaki Heavy Industry, have an advantage in that field. So so private sectors, private major players contribute to realize the hydrogen airplanes at around 2030 or so. And next is the hydrogen ship, not only hydrogen ship, but also the ammonia ship. It is a carbon neutral ships. So that's a hydrogen ship has the same program of the hydrogen airplane. It's a tank. Tank cubic volume is very important. So Kawasaki Heavy Industry, Yamaha, and Eiji and other companies collaborate with the governmental financial support and develop and realize that hydrogen and ammonia ships at around 2030 or so. It is a Japanese effort, and this air mobility, including the airplane and ships, needs a low-cost hydrogen. So Green Innovation Fund has one project. And Japan wants to construct the low-price international hydrogen supply chains. So ENEOS, Iwatani, JERA, and Kansai Denku, it's a KEPCO. KEPCO tries to realize the liquefied hydrogen transportation method, and MCH. It's used tolerant chemical reactions. Yes. So Japan will explore the low-cost transportation method of the hydrogen, and we oppress the hydrogen cost at around 2030 or so. We will realize 30 yen, it means $0.22 US per normal cubic meters will be realized by 2030, I believe. It is those are public financial support issues. And next is the private sector's challenge. Okay, since 2040, Japan, Toyota released Mirai FCV. So now about 4,600 FCVs have run in the domestic market, but Japanese government target is 40,000 FCVs. We have not reached yet. And why we can't reach the 40,000 FCVs level? It's due to the lack of the hydrogen supply stations. So Japanese government aims to increase hydrogen supply stations about 1,000 sites in 2030, but now is only 162, and now operating is only 159. So Japan need to leapfrog to increase the hydrogen supply station, but there are problem. It's a capex and opex problem. Hydrogen station cost is about 400 million yen, nearly equal to 2.96 million US dollars. And opex, operate to the hydrogen station is about 49 million yen per year. It means that 0.36 million US dollars per year. And Japanese government's subsidy granting aid for capex is about second two-thirds. It means about 60% subsidy or 50% subsidy, and for the OPEX is 60% subsidies. But hydrogen supply stations operators need to pay about need to compensate for the about 30% of the total cost. It means 136 million yen or so. Yes, or 1 million US dollars. Excuse me. H2 supply stations owners need to get profit from selling the hydrogen to the about 1 million US dollars. So, but the hydrogen price is current condition 1,100 yen to 1,200 yen per kilogram, about 8.13 to 8.87 US dollars or so. It is a selling price, but the cost of hydrogen may be equal. So difficult to get profit from selling the hydrogen supply station. It is a problem in the why Japan only 4,016 FCVs. So therefore, we need to at first we need to reduce the hydrogen's cost. Hydrogen cost about 1/3. It means current is about 100 yen per normal cubic meter, but we need to the 30 yen per normal cubic meters level. And but it is a FCV for private users. FCV. So private users are not ride 700 kilometers or so by in a week or so. So they but how about the commercial vehicle like a FC truck? They and the FC bus will consume the more amount of the hydrogen. So we can reduce the cost of the hydrogen in future. So NEDO, excuse me, Toyota and Asahi Beer. Please see this map. Asahi Beer's factory, and from factory to the Haneda Airport, they transport their beer by the FC truck. It's a kind of practical test. They evaluate how much consumes hydrogen, such a transportation truck, and so on. And Lawson, it is a major Japanese convenience store, use a small size FC truck, perhaps a 2 tons class FC truck, operated since the 2020 July 2021, 1 year ago. So, but we need more hydrogen if we operate the FC bus or FC truck in the future. It will be the 6.6 million tons per year. In Japan, we can produce only 1.92 million tons hydrogen per year, and almost 100% consumed in the site, in the factory. So we need more 66 million tons of hydrogen per year. Of course, not 120 normal cubic meter. We need a more cheaper level. So parity cost H2 hydrogen per kilogram is perhaps 560 yen. It means 4.1 US dollars per kilogram. It means 50 yen per normal cubic meter. So it is 0.737 US dollars. It will be we will reach in the future perhaps. And about the ammonia, hydrogen and ammonia ship, the parity cost is about 268 per kilogram. Yes, so that is nearly called the 23 yen per normal cubic meter. It is a little difficult to reach by the 2030, but by the 2050, we will complete that cost, I think. And airplane, yes, we will. The Japanese government facilitates preparation for the hydrogen airport and hydrogen airplanes. So as I mentioned, KHI and other major players are engaged in realizing the hydrogen airplanes and hydrogen infrastructure in the air. So sorry, too long story. So Japan make efforts, and we will prepare. We have had the finance support scheme. So the most shocking point is off-takers' motivation to induce the hydrogen transportation infrastructure, overcoming the capex and opex. So we need to more efforts to and focus on the cost reduction of the hydrogen equipment and hydrogen production cost itself. So that's all. Yes, it is a Japanese hydrogen business conditions. Okay, Mori-san, moderator. It is the end of my my explanation. My explanation finished.
Thank you so much, Edo-san. Thank you so much for sharing all these statistics, which is very valuable. And also, I appreciate your kindness for converting these Japan yen into US dollars. So for the audience, understand the situation. Yes, and for the sector, we try to push financiers out of their comfort zone. So yes, this is challenging if you consider the economics of a project. But do you have any other concerns about financing of one project? For example, do you have any technical concerns?
Yes, as I mentioned, so we make efforts to construct or brush up the financial support scheme every day. So, but technology, yes, we tend to seek for the innovative one, or innovative one, but high cost, yes, expensive system. But the expensive system meaningless for the Japanese society, I think. We need to make efforts more to reduce the cost reduction about each element, electrolyzer or liquefied tank, and so on. So we need to judge whether we investment in this company's challenge or not should be included in such a cost reductions efforts. So it is a not brilliant technology. It's a very it's a not clear or a not attractive effort, but it is essential to prepare the new infrastructure in the market. So for Japan, of course, Japan keep to seek for the innovative technology and leads the hydrogen infrastructure in the world. But simultaneously, we should make more efforts to reduce the cutting cost of each element of the hydrogen transportation infrastructure. As I mentioned, hydrogen supply station too expensive. We need to realize half cost size hydrogen supply station also. We can do that if we import the foreign companies' parts or know-how in the Japanese market and make a collaboration with foreign companies and Japanese major players. Perhaps they will realize that low-cost hydrogen supply station or a low-cost hydrogen energy management system also. So we need, we want to think, we need to think much of such investment opportunities. That's all.
Thank you very much. Yes, thank you. And as the clock is ticking, I guess we need to firstly invite our last but not least presenter of today, Mr. William Rowe, founder and CEO of Octopus Energie, who is dialing in from the UK. William, I thank you so much for your kind patience. From time to time, many people compare the energy system in Japan with the system in the UK because they are both island nations with advanced development status. Hence, personally, I'm really looking forward to your sharing.
Hi, I can't see the video. Can you see me?
Sorry? Yes, I can see you.
Perfect. I will share my screen so that we can do the slides. Fantastic. Okay. Can we see this?
Yes.
Great. Okay, well, thank you very much for having me. I'm really looking forward to speaking to everybody today. So I will be brief because I only have until 6 p.m. So yeah, I'm William, CEO and founder of Octopus Hydrogen. Our aspiration is to be the world's leading green hydrogen company. And I'm going to talk to you today around some of the solutions we're putting in place in the UK to help start the rollout of hydrogen for mobility, whilst at the same time minimizing cost. Just a brief introduction to our company. So first of all, we see hydrogen, especially green hydrogen, as complementary to 100% renewable electricity grids. So it is our aspiration to use green hydrogen production to balance more and more renewable energy sources coming on the grid. So whether that be wind or solar, our plan is to use green hydrogen to complement those renewables so that we can see more of those renewables on the grid and keep the grid balanced. And at the same time, our aspiration is to use that hydrogen for applications that won't be decarbonised through direct or battery electrification. So for example, we aren't looking at things like hydrogen for domestic heating boilers. We are focused on applications such as heavy mobility and aviation, where we don't see there being an opportunity to decarbonise through electrification. Our parent company, Octopus Energy Group, who's the major investor in us, has operations across Europe, America, and also a joint venture with Tokyo Gas in Japan. And they are a retail energy business that owns renewable generation assets and also has a technology platform. Just some brief context on the UK as well. So the UK is very excited about the opportunity that green hydrogen production, but also blue hydrogen production has in the UK. And this is a map showing all of the potential projects that have been proposed to government in the UK that are looking to go live between now and 2025. Now, I don't believe that all of these will go live, but a number of them will, and you can see they're spread out across the whole of the country. So jumping into the real detail of my presentation. So just so it's clear, we provide green hydrogen as a service. And what that means is we speak to truck or vehicle operators of what we call captive fleets, so fleets that refuel at their depot every day. And our model is to take a hydrogen production equipment, such as an electrolyzer, connect it to renewable resources directly. This avoids some of the costs of production, and also use some PPA-backed power from the grid. We then deliver the hydrogen in tube trailers to our refueling station, and then run the refueling station. And the refueling station is always designed to be private, so the refueling station is not open to the public. We keep it only open to the vehicle operator. And the reason for this is twofold. One, it lets us design the scale of the refueling equipment to be suitable for the number of vehicles, so we don't have to handle surprises in volume. And the second is it means that we can also then understand the vehicle specifics and understand the fill rate specifics. So again, we're not looking, for example, to have lots of gas at 700 bar if the vehicles are only 350 bar, but vice versa. If the vehicles are 700 bar, we need to have suitable cooling in place and additional storage, etc. So it lets us optimize and keep the costs down. We also act as a green hydrogen developer. So one of the things we found is that lots of customers come and buy hydrogen from our sites themselves in their own tube trailers, rather than requiring us to deliver the hydrogen through to them. But I wanted to touch on, we have a technology partner to optimize this hydrogen, but I don't think that's particularly relevant at this point. So this is jumping into the specific solution we're deploying in the UK now. So what we do is we have a 20-foot and a 40-foot ISO container that contains hydrogen storage cylinders. The beauty of this system is that it also has a clever set of cascade refilling capability, so actuated valves and a technology interface, and also a fueling interface, so that we can take the hydrogen to our customer's depot and then allow them to fill without requiring the build of a dedicated hydrogen refueling station. So this means that someone can start with 5 HGVs or trucks and start working, from tomorrow without needing to build a HRS. Now, as the volumes increase, so as the number of vehicles increase, this solution becomes somewhat redundant because it's inefficient to transport the gas and the refueling equipment every time, and it makes more sense to have a HRS plus with delivered hydrogen. But this is a real unlocking capability in the hydrogen market in the UK, because it means for all of the different trials and all of the different operators that want to start to adopt and learn about hydrogen vehicles, we have a low-cost solution that doesn't require a long implementation period and doesn't require a large capex investment per customer with a long payback period. So this really opens the door to allowing lots of different potential use cases to start with hydrogen. And what we're finding is it's not just road-based mobility applications such as trucks that want the hydrogen. You have buses because of policies around clean air zones. We have diesel generators, so auxiliary power systems, these are looking at hydrogen. We have excavators, so the kind of plant and machinery side of things. So there's a whole host of different applications that need hydrogen that won't yet justify the build of a full refueling station. And just a little bit of an information on how this works. So the system is designed to be pressurized to 425 bar, and then we use the overpressure and a cascade fill process to deliver fills at 350 bar. So it's a very clever system, not particularly complex, but it is a clever system that really provides the best value hydrogen we can deliver at this point in time. But we also offer the solution without the complex cascade filling, and we'll just do a straight tube trailer process. So this is for applications such as auxiliary power, diesel generators, where they don't need the 350 bar, they only need 10 bar hydrogen, and we just use the application as a straight tube trailer, for example. So that was all of the content I was going to provide at this point in time, and was hoping that we could then go into questions.
Thank you so much, William, and I apologize again for keep you waiting. Some questions we prepared for you. Number one, what are the main application scenarios of the surveys you mentioned, and who are the target customers? Can you be more specified about that?
Yeah, so we work with a lot of the major fleet and logistics companies in the UK, and a lot of the construction companies. So what we found is, and just some background information. So in the UK, until earlier this year, diesel that was being used for off-grid applications was about half the price of diesel that was going into road-based applications, because there was no fuel duty to pay on the diesel. Now, the UK government recently got rid of that subsidy, and therefore effectively now that diesel is much more expensive than it used to be. It's the same price as road-based diesel. So that's meant that green hydrogen now is competitive with the diesel on price in those off-grid applications. So the beauty of it is, for us, if you think about any large infrastructure project, so whether that be we build in railways or we build, new power stations or etc., a lot of the time there's an awful lot of diesel used to fuel the power demands during the construction phase, but there's no economic rationale to build a power connection to that site, because in the long term it won't require it. And so the beauty for us is working across the construction sector, and then with partners in the auxiliary power space, we can provide hydrogen, or green hydrogen plus auxiliary power, which then means that all of a sudden it's a zero carbon site, which is really exciting. So basically, I would say fleet and logistics and construction and events are the key segments for us.
Yeah, thank you so much for the clarification, and also about the opportunities in the UK. But during your expansion of the business, what challenges do you encounter most?
So the biggest challenge we faced in the last 2 years has been around the supply chain. So I think because a lot of the hydrogen related equipment is relatively immature, and especially on the green hydrogen side, so things like electrolysis, compressors, and refueling equipment, there's often delays to those items within the supply chain. And the problem with that is, because there's not backup options, there is not a set of standardized products that exist in the market. The challenge is you can't really plan around having redundancy in your supply chain to the same extent you'd like. So you do really suffer with those supply chain issues. So for us, we just keep trying to form richer partnerships with our supply chain, so that we work with them around their problems, rather than let's say just looking at a contract, because simply standing behind a contract isn't going to be enough to get those supply chain issues resolved.
Yes, and assume you have the power to change the situation. What would be your method? I
think ultimately, the reason why we work with a supply chain is because there's certain elements of hydrogen production equipment, or refueling equipment, etc., that we don't want to be involved with ourselves. So we are not an engineering firm that builds certificated products with relevant safety cases and documentation. That isn't something we want to do. We want to buy those products and services. What we want to do is focus on bringing those things together in a business model that works for the end customer, and then using our technology to optimize those sites to provide benefits to the grid. So for us, I guess I don't want to go further down and into the detail of how you make a certified product, and we want the companies that do that well. What we want is to focus on that kind of the customer facing side of things. I think the biggest challenge from a customer perspective is the fact that because power prices around the world have gone up a lot due to the Ukraine crisis, this has meant that ultimately green hydrogen, although in principle is now more competitive than fossil fuel derived hydrogen, the reality is it still suffers due to the high cost of power. So we would definitely like to see lower power costs in the medium term.
Thank you so much, William. I know you have a meeting in 6 minutes, so I won't bother you. Thank you so much again for joining us. So, could hydrogen be the lifesaver for Japan's energy transition? How is hydrogen and the fuel cell formulated into Japan's decarbonization strategy? What road and roadblocks as we look ahead into 2030 and 2050? Bearing these questions in mind, today we are more than honored to speak with Mr. Eiji Ohira, Director General of the Fuel Cell and Hydrogen Technology Office of NEDO, Japan. Ohira-san, on behalf of Leader Associates Impact, I welcome you here. So before we get the presentation started, may I firstly invite you to say hi to the audience and briefly introduce yourself, your role, and how that relates to the Japan hydrogen and fuel cell development.
Thank you, Molly, for the kind of introduction. My name is Eiji Ohira. I'm the director for the hydrogen fuel cell office and of NEDO. NEDO is a kind of funding agency under the Ministry and Trade, Economy, Trade and Industry. And we are promoting the several national R&D program. And the hydrogen is just a part of, but a very promising area which we and NEDO are working for. And we have a long history and working for the hydrogen fuel cell from the since in 1980, and when we were established. But recently, as I mentioned, that hydrogen fuel cell, most of it, one of the very promising technologies we are strongly working for. I'm very happy to join this conference, the webinar, to provide several information.
Thank you so much, Ohira-san. You're absolutely right that NEDO is working closely with the government goal setting and the pilot project development. Hence, your insights into the market are very much needed for the industry to understand the current focus and the future. So now, if I may, I'd like to turn the floor to you and have you formally start your presentation.
Thank you. I hope I can.
Yes.
All right, and thank you very much. And then I mentioned that today I would like to share the kind of information how we Japan and promote hydrogen. Well, let me start at the current situation, the background, and with our activities. And this is Japan current energy situation for the primary energies on your left side. And recently, our renewables increasing every year and currently reach the 10% of the total energy sources, total primary energy sources, and 20% in total.
Hello, Ohira-san. I think I lost your voice.
We need to improve, increasing the renewables. But on the other hand, you may see our current carbon dioxide emission from the energy sectors. Energy transition, including the power sector, showed a huge part of the carbon dioxide emission. To tackling carbon neutral or zero emission. We are sort of working for the promoting the decarbonization, the other sector like industry and transportation, the commercial, residential, and so and hydrogen is sort of the part of is a very important part of our challenges for improving the self-sufficiency rate and tackling the climate change issues. And I would say that Japan policy update, and at the late Japan also declared that our energy and environment target, which is net zero carbon neutrality by 2050. And to achieve our goal, Japan, mainly the METI, have provided several policy measures. So one of the big events is to funding. And METI formulate green growth strategy as well as achieving a national strategy and establishing the Green Innovation Fund. It's approximately $19 billion to accelerate in several technology for carbon neutrality, including the large-scale hydrogen transportation, hydrogen power generation, renewable hydrogen, maritime and aviation, steel production. And also, I'd like to mention that Japan's energy policy for 2030. Japan unveiled a new energy mix in 2030. It's increasing the renewable, still keeping the nuclear. That I will say that its new one is put hydrogen, ammonia at the position in a 2030 energy mix. It's the first time. It means that Japan's government recognized the hydrogen. It would be the one of the energy option and with reality, right? This is the kind of the image and how we Japan achieved the carbon neutrality, well, and promote utilization of the electric power in non-electric power like transportation and the thermal energies and etc. etc. It means to convert from the thermal energy to the electricity. And also we put zero carbon power as combination the renewable nuclear fossil fuel plus CCUS and also the hydrogen and ammonia. In the area, still electrification is quite difficult, and hydrogen and ammonia and the biomass are used directly. And the specific action and the target value will be considered in the future. That shows this kind of image how we achieve carbon neutrality. And this is the direction how we have promote hydrogen. Our challenge is to reducing the cost of the hydrogen and to $3 per kilogram in 2030 and $2 less than the $2 kilogram per by 2050. This is the many hydrogen costs, but this cost is hydrogen and at port. We plan to import the hydrogen, that the cost of transportation, the hydrogen production in the other countries. And the 2030 is a very important year for us. It's kind of the turning point for Japan, for the hydrogen society. We like to start import hydrogen and from the 2030. And we started hydrogen power generation, hydrogen gas turbine power generation starting in 2030. We started the domestic renewable hydrogen in the 2030. It's a very important year. Toward the 2030, we're working so for very help for developing the technologies, developing the social systems, a system including the regulation code and the standard or any policy measure. Right, let me talk about the current status of the hydrogen fuels application. And our first commercial application is a stationary fuel cell, residential fuel cell, namely Endo. And it's launched almost 10 years ago, 2009. Now we have over the 400,000 units around Japan. In the mobility sector, we have already 7,000 passenger vehicle, mainly Toyota Mirai, and fuel cell dominant in the buses running and mainly in the Tokyo city area regularly, and its number of the buses over 100. And the public station, hydrogen filling station, that is the key for the dissemination of the mobility, fuel cell mobility. Now we now 160 hydrogen filling station in operation. And the next, let me talk about NEDO's activities. And, as I mentioned earlier, and we organized several national and projects, including the hydrogen fuel cells. Well, we take and we're working for the hydrogen to production and storage and transport and utilization, for the basic research, applied research, and demonstration, etc. And now there's the hydrogen and the fuel cell technology, and the hydrogen production, etc. But this shows kind of our strategy, step-by-step approaches. I know first right now working for to commercialize the residential fuel cell, and this is kind of bring the fuel cell application into the digital market. As I mentioned, that it succeed commercialization in 2024. And the next step 2 is realizing the fuel cell vehicle and the hydrogen filling station. Yeah, and the fuel cell vehicle provide a good environment and option. But the most important thing is this application, through this application, is a direct use of the hydrogen as energy sources in the society. We need to develop, not only a technology, but also the kind of social system. I mentioned that regulation code standard, etc. Will they succeed at commercialization in 2024, as you know? And the next step is how to develop, how to expand the hydrogen demand. I mean that we may use hydrogen in energy system. That's the key, currently key. Let me talk about the snapshot of recent project. And this here shows our working for our efforts for hydrogen gas turbine. We may use the hydrogen and instead of the liquefied natural gas for the power generation. Then we're working with a small size and hydrogen gas turbine and then large scale. Or hydrogen and natural gas. Well, we try to expand the size of the hydrogen gas turbine, and as I mentioned, that realize it in 2030. Okay. And Japan need to import and hydrogen in the future. Well, the challenge is how to concentrate and hydrogen for long distance and transportation. And one of the choice is liquefied the hydrogen. We already have developed a small but the world's first hydrogen and tanker, and also the to some of the liquefied hydrogen the handling equipment at port. We are still continue to working for the demonstration, and we are investing a huge amount of money to scaling up this liquid hydrogen or any other hydrogen carrier international transportation. And also power to gas is quite important for realizing kind of green-based energy systems. There are key technologies and to electrolysis. And we Japan are conducting the megawatt scale on the power to gas in the 2 areas. And one is in Fukushima Prefecture in the very northern part of Japan. It's based on the Asahi Kasei megawatt alkaline water electrolysis. And the other one, and it's to Yamanashi Prefecture, the center of Japan, with 1.5 to 2 megawatt PEM water electrolysis developed by the Hitachi Zosen Corporation, and to using the tolate and the hydrocarbon membrane with the high efficient membrane technologies. Well, we will start to continue the demonstration, and the next step is scaling up and to through the 100 megawatt plus in several years. In the last way, and let me talk about our demonstration project and at port. Well, we try to develop localized and hydrogen and utilization model. This figure is an overview of our current effort at the port in Los Angeles, California. And, from the viewpoint of the air pollution control, electrification at port equipment, in fact, it became an important issue. Well, and battery is an option, and hydrogen is a very most promising option. Implementation for electrification at port. We try to develop the several Hirose applications like a top 100 to country grain, and the truck, the DH truck, and the install and the testing the usability at port. So, and let me conclude my presentation. And hydrogen is not a single solution, but a key technology for the carbon neutrality. Where Japan has become strongly promoting hydrogen, and we are working for the hard, but still continue to expand in our effort. We just start market penetration on the hydrogen fuels application, but we need to expand our application, also improving the technology itself. But our goal is not only to disseminate in the fuels application, but also developing the low carbon energy system. We're working on the several approaches, but the key work is in scaling up for integration with other energy systems. Well, with Japan, again, Japan is working on the hydrogen very hard, and also to including collaboration in other countries. Thank you very much for your attention.
Thank you so much, Ohira-san, for the very informative and thought-provoking presentation. I think the industry is inspired by NEDO's efforts and is looking forward to collaboration with your side. In the meantime, we have also received several questions from the audience to you. If I may, can we accommodate 2 or 3 questions here? Yes, the first one goes to the market comparison. So from your perspective, is there a different focus for the hydrogen economy in Japan compared with that in the European Union? Or more specifically, compared with the strategy in Germany, in France, or in the UK as an island nation?
Okay, I think that's quite a very important question. And as I mentioned, that in the hydrogen market has not developed yet. So not it's not and well talk about the details. And but we are all over the world and working for developing hydrogen in the market. But the approach is a little bit different, especially and developing the first demand. As I mentioned in my presentation, Japan that tried to develop the hydrogen demand and through the hydrogen gas turbine, hydrogen power generation, cooperate with to power company in Japan. But in my understanding in Europe and working collaborate with the industries, hydrogen utilized in chemical and steel production and at the refinery also. Both approaches in the future is quite important in the future, but starting approach, early stage approach, is a little bit different. That's in my view.
Thank you. I think you just mentioned the challenges, the constraints we see in this industry. And the next questions, again, is about the constraints. So when we talk about the lack of demand, the lack of balance between the demand and supply, the lack of commercial viability. So what are NEDO's response to address these challenges?
well, it's a big, quite important, quite difficult challenges, you know. We recognize that there is a quite early stages, and again, that the hydrogen and fuel cell market has not developed. In this case, in the issue is how to how to involve the industry in this field, and this is quite a governmental leadership. It's quite very important, and government leadership is mainly the message how which Japan transform, how the world in a transform to, for the future. As I mentioned, to understand that energy transition, it needs a quite long term, to 10 years and 20 years. But a strong message is quite important. A strong message, and we do that. We may invest in this area, well, etc., etc. Not a single country, and then multiple countries also. And we are collaborate with the Japanese government to provide the Japan message, to show the huge amount of the money for the R&D area. You know, we also to collaborate with other countries to develop the momentum to promote the hydrogen. So through this activity, we have believed we can to involve any industry around the world to realize in the hydrogen-based market, hydrogen-based society and the hydrogen market.
Yes, and narrowing down to the hydrogen in Japan's transport sector. So how much demand do you foresee hydrogen in the Japanese transport market, including the mobility market, the heavy duty market, etc.? And what are the immediate opportunities you see? And what are the opportunities you see in the medium and long-term scenario?
Yes, I didn't have any concrete scenario of how to change, transform to get the combustion-based transportation to the electrification-based transportation. But now we are now developed at a very early stage. Yes, we Japan launched the commercial, passenger vehicle, and also several years ago, but still very early stage. We need some experiences. It's kind of demonstration. And through the 2030, as I mentioned, the 2030 is quite important, and we expanded the passenger vehicle, not only passenger vehicle. And from this year, we are working for the demonstration for commercial vehicle, truck, small, medium, heavy duty trucks, and also we try to expand in the high fuel cell buses. And so combination with the passenger vehicle and commercial vehicle, we are still keeping the continue to working for the expanding this and the fuel cell vehicle. But remember that, and to battery electric vehicle and the fuel cell vehicle, we not compete. Both of technology, it's just electrification of the to transportation, and the customer may choose and based on their needs, and we must not provide which is better, and the customer may choose battery and fuel cell.
Thank you. And also, the hot wave of hydrogen is because it's linked with energy independence, energy security of a nation. But for Japan, imported hydrogen, imported alternative fuels are still imported fuels. So there's also a conversation domestically regarding the imported hydrogen and alternative fuels versus locally produced hydrogen and alternative fuels. For example, using offshore wind plus hydrogen, or using nuclear to produce hydrogen. So what does NEDO perceive the trend, I should say?
Well, we are not in the R&D to promoting organization. We cannot talk about in the Japan energy policy, but in the personal opinion, yes, and Japan tried to expand our renewable, not only the PV, well, including the offshore wind also very, very promising resources in the future. But it's very difficult to cover all of the Japan's energy demand because Japan's energy concentrated country. And to merit of the hydrogen can be produced several many from the many resources, and from the coal oil to natural gas and renewable, etc., etc. So we have the chance to develop the new resource countries, and on the kind of political stable, including political stable company. Countries, whatever. And energy security is very important, and we also to secure the energy security, we find in the new energy continuing the new countries to collaborate in this field and for the stable securing the stable energy. But also to try to expand in Japan's energy self-sufficiency rate, we still have the very small, the 10% and around 10%. But we try to expand it to 20%, 30%, 40%. But still, we must second import the energy sources or to good relationship. It's quite very important for us. There's a combination.
Right, the mix, the diversity.
Yes.
So one last question to wrap up the Q&A session. So it's regarding the energy carriers. In the last slide, you mentioned that NEDO is doing some initiatives for hydrogen at ports. And actually 2 weeks ago, we conduct an interview with the port authority from Singapore, from Japan, to understand their concerns at the moment. So they told me that their concern is the lack of focus on the technology choices. If they want to invest for the infrastructure, they need to understand what kind of carriers will be.
Well, and it also need
market.
Sorry, and this maybe to the energy carrier question, it's quite related to and color of the hydrogen question. Well, we also asked which color and of the hydrogen Japan to promoting the blue, gray, and green, etc. Sorry, not gray, blue and green, etc. Which is better. And I would say that if we import hydrogen, and the point is the cost of the hydrogen, and also the carbon intensity of the hydrogen. We not care. It's not concerned about the color of hydrogen. And also, we are concerned of the energy carrier, hydrogen carrier with the liquefied hydrogen and organic chemical hydrates, etc. Our job, our role is providing the technological option and for liquefied hydrogen and organic chemical hydrate, and industry may choose to based on their philosophy or their resources, right? And if they have their very close to the chemical resources, they have the chemical resources or the oil relevant resources, may choose the organic chemical hydrates because it's very familiar to their business. If they are working for the to liquefy the hydrogen, and they may choose the liquefied hydrogen because they may use their asset, including the human resources, and so I cannot say, I must not say that which is better and of the energy carrier of the color of hydrogen, but it's based on decision of the industry. So it's not direct answer to you.
Understood. Let the market decide for itself. So thank you so much, Ohira-san, for your kind and generous sharing. As much as I'd love to have you talk forever, I must let you go for the upcoming meetings. Again, I thank you for joining here. I really enjoyed talk, and I hope you enjoy the same way I do.
Thank you very much. I quite enjoyed it.
Thank you so much.